Today, let's learn about permutations and factorial, some important tools for probability. A permutation is an arrangement of all or part of a set of objects. This word is incredibly important. Arrangements are like how many different ways can you mix that order up? Okay, so order is really important for permutations. Let's look at a simple example. I've got 3 plants here. I'm going to call them the yellow cactus, the jade plant, and the red cactus, just to simplify things. So how many different ways can I arrange these plants? All right, and it turns out that this is a very mathematical thing, and it's an important thing because we will use this to determine how big a sample space is for probability. Let's look at a couple of methods that I'm going to suggest. One is a really basic way to do things that I'm going to call listing. All right, if I just take my potted plants and I start writing a list of all the ways I think I can mix them up, that works pretty well. So for example, if I put yellow first, I could put them just the way they are, yellow, jade, red. Or by putting yellow first, I could also put the red one next and then the jade plant, right? I think that's the only 2 ways that I can arrange it, putting yellow first. So let's try putting jade first. If jade was first, then I could do yellow followed by red, or I could do jade, red, yellow. And of course I could do red first. So if red was first, I could do yellow then jade, or I could do red and jade and yellow. And at this point, if you're thinking about, wow, she wastes a lot of time trying to decide how to arrange her plants on a shelf, that is true, but it's all for the higher purpose of mathematics, so hang in there with me. All right, so according to my list, that's all I can think of. I can't think of any other arrangements. So 1, 2, 3, 4, 5, 6 different ways. So my answer would be 6 ways. Now, I don't know if you can already see that the limitation here for listing is that you might just not see something. You might make a list that's incomplete and get the wrong answer. But it's a pretty good way to do things if there's not very many objects. I've only got 3 plants. That wasn't too tough. 6 different ways I can mix them up. Who knew? Okay, well, tree diagram is another way, and it's a little more guaranteed to be complete. So let's see how it starts. You want to think of a tree diagram in phases. So my phases could be the 3 locations, like here, here, and here. I've got 3 locations for plants. When I think of the first location, I could put any of those 3 plants in it. So I make 3 branches to represent that. Here are my 3 branches for the first location. So I'm going to call it number 1. For number 1, I could put either the yellow one there, or I could put the jade plant, or I could put the red plant. This is not an order. These are my choices for the first location, for right here. Okay? Now, once I've put a plant there, one of those plants has been taken. So, for example, if I put the yellow plant there, when I go to choose what gets to be in the second location, I'm going to put a number 2 up here. For the second location, I can't choose yellow again, so I really only have 2 choices. Now, I either could choose jade or red. Those are my 2 choices. And if I had put jade first, then I also only have 2 choices, but they're different, yellow or red. And if I put red first, now I could either choose jade or yellow. Order does not matter on the tree diagram, okay? It just is a way of displaying all the choices. So, and as they branch out, the number of objects in that final column is going to be our number of choices. So now I've chosen what goes in the first spot. I've looked at all the choices for the second spot. Now we're going to look at the third spot, okay? The third and final place. And here's how it works. This is one of the arrangements appearing right here. So I've got yellow followed by jade. The only thing I can do is put red. So I really only have 1 choice now. Or if I had done yellow followed by red here, then my only choice is to put jade. Okay, so you fill in the chart similarly. So now I have written out all the possible choices for arrangements for 3 places to put plants. This turns into a list. So in order, that's yellow, jade, red. This one would be yellow, red, jade. And you can just fill it in. Okay, so there's my complete list. Now you might wonder, wow, that's a lot more work for making a list than the list method was. True, but I hope you can also see that because I used a tree diagram, I'm pretty sure now I have not missed anything. And so the answer is how many ways? 6 ways. Now the tree diagram is important for another reason. It is starting to hint at the mathematics going on in the background for permutations. Think about it this way. For that first location, how many choices did I have? I had 3 choices, right? For that second location, how many choices did I have? I had 2 choices for each of the 3 choices. So I had 3 of those 2's, which we know is like multiplication. So you could think of that as 3 things times 2 things. And then how many choices did I have for the last location? Well, once you've chosen 2 things, there's only 1 thing left to choose for each of the previous choices. So we would multiply that by 1. And this 3 times 2 times 1 is where those 6 things are coming from. And that's a really important pattern. Let's see what else we can do with permutations. Here's a group of 6 kids waiting in line for something, right? How many ways can I arrange these kids in different orders? That's what permutations are. We're looking for how many permutations. I'm going to show you something now called the slot strategy. Instead of a list, instead of a tree diagram, we're going to do something a little different, but I want you to remember the tree diagram. I'm going to make 6 slots that represent who's going to stand in what order. When I choose who gets to be in the first slot, how many kids do I have to choose from? Well, anybody could be in the first slot, so that's 6 choices, right? Once one of those kids has been chosen, how many kids are left to choose from for the second slot? Only 5. I think you can see where this is going, right? So I've got 2 kids now locked in. I have 4 to choose from. After 3 kids are locked in, I have 3 to choose from, and then 2, and then 1. If you imagine a tree diagram, what this is 6 branches with 5 branches at the end of every branch. So that's like 6 times 5 with 4 branches at the end of all of those branches. So that's times 4 times 3 times 2 times 1. And that is, let's see, since it's multiplication, I can do it in any order I like. And I like to do 6 times 20 is 120 times 6 would be 720. You can, of course, do that on a calculator. I just like the challenge of doing these things in my head. And with multiplication, you can do it in any order that is the most advantageous for doing mental math. So that's what I did. So there's actually 720 different ways, and that's your unit for this. Now, here's a new problem. How many ways can we mix up the alphabet? Oh boy, this is going to be fun. Shall we use the list method? Well, let's think about that for a minute, okay? Our list would look something like, there's a lot of answers. In fact, think about this. Just putting A first, you could write out 25 different letters for the next thing just with A. So there's 25 different ways to write the alphabet with A first, and that's just A. So I don't want to write a list for this problem. How about slot method? It's more efficient than list method for sure. But in this case, you would have to write 26 slots, and that's just time consuming. I have 26 letters to choose from. I have 25 letters to choose from. I have 24, and I would multiply. You can see that maybe you don't have to write it all down. Maybe you could just start putting those into your calculator and multiply 26 times 25 times 24 times 23 all the way down to 2 or 1. 1 is included, but you may have already noticed by now that that last step, that times 1, doesn't really change anything, does it? Anyway, you could put that in your calculator. That's going to take you about 30 seconds. That's quite a bit of time for a multiplication problem. But at least it's more efficient than list or tree diagram, right? What if there was a way that I could just do this calculation in one step? Well, there is, and it's called factorial. Factorial is awesome for these problems. It turns out that there's a function that does this for you. It multiplies any number by all the positive integers less than that number, and it's called factorial. Its symbol is an exclamation point, probably because it's so awesome that it does this. So for 26, we would write it this way. 26 factorial means 26 times 25 times 24 times 23, etc. And you can just plug it into your calculator, and all scientific calculators and graphing calculators do have a factorial function. So it is time for you to figure out where that is. It's either a button or you have to go into some function menu and find it. It'll be with the statistical and probability stuff, okay? So anyway, factorial, wonder what this answer is going to be. Oh my gosh, this is huge. Here's the answer. All right, if you want to try to read it, you say this. Have fun with that. That is a very big number. Let's see what else there is to learn.